Hi, I thought I would work an extra example for you guys. I often get this complaint from my students that I don't work quite enough examples in class and that when I do, I go too fast. So feel free to pause me at any moment if you feel like you can't keep up. So let me pull up the example. It's a unit conversion example, and it wants you to convert the U.S. national debt on August 16th of 2012, which is roughly $16 trillion. If it says that the payments are made at the rate of $1,000 per second, how many years would it take to pay off the debt, assuming it doesn't increase and no interest were charged? Also, Part B wants you to do a dollar bill is 15.5 centimeters long. If the debt were laid out in $1 bills end-to-end around the Earth's equator, how many times would they encircle the planet, taking the Earth's radius to be 6,378 kilometers? So that's the example. Okay, now I've worked this out for you on Classroom Presenter here. So for Part A, where they want you to convert $16 trillion into a time in years that it would take to pay it off, you're going to first go from 16 trillion here to seconds and then to years. So $16 trillion, here's my units, here's the dollar bill sign. 16 trillion is 16 times 10 to the 12. And then if you pay it off at the rate of $1,000 per second, then you convert to seconds pretty easily. Now, this little example here gives us time to look at this. If you're going from dollars to seconds, then you have to divide out by dollars and multiply by the seconds. I usually set up this little conversion matrix here. I put anything that I want to cancel out diagonally from one another. See, what you do is you multiply by everything that's on the top and divide by everything that's on the bottom. And then if you do that, you end up with 16 times 10 to the 9th seconds. Now you just need to take this time and convert it from a time in seconds to a time in years. But first we have to figure out the number of seconds in 1 year. So given leap year, on average, every year has 365.25 days. So if I take that time in days and then I convert to seconds, I'm going to have days diagonally, and then 24 hours in 1 day. And then from hours to minutes, we have 60 minutes in 1 hour, and then 60 seconds in 1 minute. So you can see here, days cancel, hours cancel, minutes cancel, leaving seconds. And if you do that, oddly enough, there's about pi times 10 to the 7th seconds in 1 year. Here, 3.1557600 times 10 to the 7th seconds in 1 year. Okay, so now that we know the number of seconds in the year, I can convert this 16 times 10 to the 9th seconds into years. So I'm going to put them diagonally across from one another here, and then 1 year is that many seconds, so I divide by everything that's on the bottom, and I end up with about 507 years. So that's how long it would take to pay off the national debt if we paid off $1,000 every second, assuming no interest. Okay, now Part B said to figure out, if you laid the dollar bills end to end, how many times that would wrap around the Earth at the equator. So what we want to do is take the debt, dollars, and then convert that debt into a length if you had $1 bills, and then that length into a number of times it would wrap around the Earth, which is of course the circumference of that circle. So to find the Earth's circumference, any circumference of a circle actually, it's just 2 pi times the radius. So that's 2 pi times 6,378 kilometers, giving you this number here, 40,074.16 kilometers for the circumference of the Earth. Okay. Next, you're going to take that dollar amount and you want to convert it to the Earth's circumference. So I've set up my little matrix here. First, I'm going to convert from dollars to a length. So I cancel out dollars and I leave length on the top, 15.5 centimeters, which was the length of $1 bill. Now that I have the length in centimeters, I need to convert it to kilometers because that's what my Earth's circumference dimension is, kilometers, not centimeters. So I'm going to convert first from centimeters to meters and then meters to kilometers. So you can see how I do that. And then next I want to convert from Earth's circumferences, from a length to an Earth's circumference. So to do that, I've got my in kilometers, and then I have Earth's circumferences on the top. So multiplying by everything on the top, dividing by everything on the bottom, I end up with 61,885.3 times the number of times that the national debt would wrap around the earth if it were laid into dollar bills. So that kind of puts the size of the national debt in context a little bit for you. And I hope that it also gave you another nice unit conversion example that you can use to help you do your homework.